Hello everyone. Today we are going to learn about nuclear energy in 15 minutes. I hope all of you will sit tight and focus in this lesson. In this video, we will be exposed to Content Standard 6.2 Nuclear Energy. There are two learning outcomes that will be covered in this video. The learning outcome that will be covered are 6.2.1 Communicate about nuclear reactions, which are number 1, nuclear fission, and number 2, nuclear fusion. At the end of this lesson, all of you should be able to compare nuclear fission to nuclear fusion. The second learning outcome will be covered are 6.2.2 Describe relationship between energy released during nuclear reaction and mass defect. E equals to mc squared. At the end of this lesson, all of you should be able to discuss atomic mass unit using mass of one atom carbon-12 and the Avogadro number. Do you guys know nuclear power provides 52% of America's clean energy? In 2020, nuclear energy provided 52% of America's carbon-free electricity, making it the largest domestic source of clean energy. Moreover, nuclear power plants do not emit greenhouse gases while generating electricity. Let's start our lesson with nuclear reactions. Nuclear energy is the energy in the nucleus of an atom and also known as atomic energy. Atomic energy is released by the reaction within the atomic nuclei. There are two types of nuclear reaction. Number 1, nuclear fission, and number 2, nuclear fusion. Both nuclear fission and nuclear fusion release a large amount of energy. The first type of nuclear reaction is nuclear fission. Nuclear fission is the splitting of the nucleus of heavy atom into two lighter nuclei, which emits either 2 or 3 neutrons and releases a large amount of energy. The examples are in uranium and plutonium. Let's take a look at the nuclear fission of uranium-235. As we can see at number 1 process, a uranium-235 is bombarded by a slow-motion neutron. Next, the nucleus of uranium-235 becomes unstable with extra neutrons. As a result, it splits into two smaller nuclei, which are krypton-92 and barium-141. And at the end, 3 neutrons and a large amount of energy are released. This nuclear reaction of uranium-235 can be represented by the equation as follows. The second type of nuclear reaction is nuclear fusion. Nuclear fusion is the combining of two lighter nuclei to form a heavier nucleus with the release of large amount of energy. The example of nuclear fusion process is nuclear fusion of deuterium and tritium. Let's take a look at the nuclear fusion of deuterium and tritium. The figure shows the process of nuclear fusion of deuterium and tritium. Firstly, the nuclei of deuterium and tritium fuse to form a helium and a nucleus. Next, a neutron and a large amount of energy will be released. The equation of this nuclear reaction can be represented by another example of nuclear fusion is nuclear fusion of hydrogen. Nuclear fusion of hydrogen to form helium occurs naturally in the Sun. This reaction takes place only at extremely high temperature and pressure. Here are some comparisons between nuclear fission and nuclear fusion. Number 1. In nuclear fission, a heavy nucleus breaks up to form two lighter nuclei, while in nuclear fusion, two light nuclei combine to form a heavy nucleus. Number 2. In nuclear fission involves a chain reaction, while in nuclear fusion, chain reactions is not involved. Number 3. In nuclear fission, the heavy nucleus is bombarded with neutrons, while in nuclear fusion, light nuclei are heated to an extremely high temperature. Number 4. In nuclear fission, disposal of nuclear waste is a great environmental problem, while in nuclear fusion, disposal of nuclear waste is not involved. Number 5. There is a proper mechanisms to control fission reaction for generating electricity, while in nuclear fusion, proper mechanisms to control fusion reaction are yet to be developed. Next, let's move on to the relationship between energy release during nuclear reaction and mass defect. Atomic mass unit is the unit mass for an atom. The atomic mass unit is used as convenient unit because the mass of atom is very small to be measured using gram or kilogram. An atomic mass unit is 1/12 of the mass of carbon-12. As we all know, an atomic mass unit is 1/12 of the mass of carbon-12. Therefore, since the mass of one carbon-12 atom is 12 atomic mass unit and 1 mole of carbon-12 has 6.023 times 10 to the power of 23, which also equal to Avogadro number, the mass of one carbon-12 atom can be obtained by 12 divided by 6.023 times 10 to power of 23 equals to 1.992 times 10 to power of negative 23 gram. Then the value must be converted into kilogram equals to 1.992 times 10 to power negative 26 kilogram. Continue from the previous calculation. From the definition of atomic mass unit, where n atomic mass unit is equal to 1 over 12 mass of carbon-12, by substituting the mass of one carbon-12 atom calculated previously, one atomic mass unit is equal to 1.66 times 10 to power of negative 27 kilogram. Next, to know the relationship between energy released during nuclear reaction and mass defect, let's learn about mass defect. So, what is mass defect? Both nuclear fission and nuclear fusion release large amount of energy. This source of energy is from the loss of mass in those nuclear reactions. This loss of mass is known as mass defect. The loss of mass means that the mass had changed to energy. Therefore, the relationship between energy released during nuclear reaction and mass defect is as follows. E equals to mc squared, where E is equal to the energy released in unit joule. M is equals to loss of mass or mass defect in kilograms. And C equals to the speed of light. Now that we have finished the lesson for nuclear energy, let's test your understanding. Let's start with the first question. In the Sun, energy is released when hydrogen nuclei collide and form heavier nuclei. This process is called nuclear fission. Based on the statement above, is it true or false? The answer is false. The process of combining of two lighter nuclei to form a heavier nucleus is called nuclear fusion. Next, for the second question, when a sample of radium-226 decays, the energy released is 7.81 times 10 to the power of negative 13 joule. What is the mass defect? The answer is 2.6 times 10 to the power of negative 21 kilogram. This question can be solved by using the equation E equals to mc squared. That's all from me on nuclear energy. Thank you for your attention.